In this video, I want to continue our discussion of how we diagnose whether we have an AR1 process or whether we have an MA1 process. And to do so, we need to note the covariances which we derived in the last video. So for an MA1 process, the covariance looks something like this, where often we use the Greek symbol gamma to represent the correlation. So the correlation for the eighth step in the future. So one way to diagnose whether you have an MA1 process or an AR1 process is to get your statistical software program to draw a correlelogram. So a correlelogram is just on the x-axis here we have h, so we start off with h equals 0, then we talk about 1 step in the future, 2 steps in the future, 3 steps, etc. So that's the x-axis. On the y-axis we actually have what is actually measured in our sample as the correlation. So for all series the correlation for the 0th step is going to be 1, so you normally get it in bar form, and the first bar just has a height of 1 because the correlation of any series with itself is just 1. And for an MA1 process, the next actual correlation will be for when h equals 1, we'll have something which looks like this. Yep, so we'll have a height which is something like that. And for an MA1 process, all other correlations after that should be approximately 0. They won't in practice be exactly 0 because of sampling error, but they will be around 0. So that's what an MA1 process will look like. Whereas if we contrast this with what an AR1 process will look like in terms of its correlelogram, we will have something, if I just label this correlelogram a bit so we can compare it with the above, 0, 1, 2, 3, 4, etc. Then it's similarly going to have a correlation of 1 for the 0th lag. So that's going to have a height of 1. Then after one period, it's going to have a height of rho. So it's going to look something like that, where rho here I've chosen to be something like around 2/3. And then after 2 periods, it's going to go down to 2/3 of what it was in the first period. So it's going to be like that. And then in the third period, we're going to have something like that, and etc. It's going to decline. There should be an exponential decline in your correlation or your correlelogram. So this is what an AR1 process would look like. And perhaps it would actually decline a little bit sharper than I've shown there. So after a finite number of lags, it will be kind of indistinguishable from 0 in terms of the correlation. So that's a way of diagnosing whether you have an MA1 process or an AR1 process, but also an MA1 process which has a correlelogram which looks something like this actually allows you to estimate the parameter theta. And to do this, all we have to do is we actually have to note what the correlation which we found in our sample was in the first period. So we just note what we actually found in our sample for the correlation, which I'm going to call R or R1. And then what we can do is we can kind of do a method of moments estimator for the parameter theta. So we just say that theta hat divided by 1 plus theta hat all squared is equal to what we found in our sample R, which if we then solve for this, it turns out we're going to have a quadratic in theta hat, and we find that theta hat is equal to 1 plus or minus the square root of 1 minus 4r squared, all divided by 2r. So it kind of suggests that there might be 2 solutions. But in fact, it turns out there's only one solution, which is the 1 minus this square root term here. And I won't go into it now, but the reason that it actually comes about is such that our process is what we call as being invertible. And as I say, I'm going to cover that in future videos in this course, but I don't want to discuss it now. It's not really important for our purposes right at this moment.